Webb's first direct image of another world was never meant to be the ending. It was the opening scene of something much larger. What came after was even more astonishing. A giant planet glowing in infrared darkness. A possible ocean world hidden beneath a hydrogen-rich atmosphere. A scorching planet where stellar radiation drives strange chemical reactions. And an entire planetary system that seemed full of Earth-like possibilities until Webb looked closer. The deeper Webb goes, the less familiar these worlds become. And that may be the most important discovery of all. The galaxy is not short on planets. It appears to be overflowing with them. But the closer we get to studying those worlds, the more we realize that finding a planet is only the beginning. The real challenge is understanding what kind of world it actually is. That is where Webb has changed the search for life. For decades, astronomers found thousands of exoplanets without ever truly seeing most of them. A star would dim slightly. Its light would wobble. A repeating pattern would appear in the data. Those clues could reveal the presence of a planet, estimate its size, and help determine its orbit. But the planet itself remained hidden. We knew it was there. We simply could not point into the sky and say, "There it is." Then Webb changed the picture. One of the clearest examples came with HIP 65426b. At first glance, the image does not look spectacular. There is no detailed alien landscape, no visible ocean, and no clouds stretching across a foreign sky. Just a tiny point of light separated from the brilliance of its star. But that faint point is a planet. A real world orbiting another star. And Webb did something extraordinary to see it. Instead of observing the planet in ordinary visible light, Webb detected it in infrared wavelengths, where the young, hot planet shines strongly enough to be distinguished from its star. Webb's instruments and coronagraphic techniques helped suppress the overwhelming glare of the star, allowing astronomers to isolate the planet's faint signal. The result was not just an image. It was proof of what the telescope could do. HIP 65426b is a massive world, several times the mass of Jupiter, and it orbits remarkably far from its star. It is young, hot, and still radiating energy from its formation. And that creates another mystery. How did a giant planet end up so far from its star? Did it form where it is today? Did it begin much closer in and get thrown outward? Could gravitational interactions with another planet have reshaped its orbit? Was its early planetary system violent and unstable? The image could not answer those questions. But that was precisely what made it so powerful. Seeing another world was not the end of the investigation. It was the beginning of a much harder one. Once astronomers can separate a planet from its star, the next question becomes unavoidable. What can that planet tell us about itself? That question leads directly to K218b. Unlike HIP 65426b, K218b was not famous because Webb captured a dramatic direct image of it. It became important because Webb could study the chemistry of its atmosphere. K218b is larger and more massive than Earth, orbiting a red dwarf about 120 light-years away. For years, it stood out as an intriguing exoplanet, but there was still enormous uncertainty about what kind of world it actually was. Then Webb examined its atmosphere. When the planet passed in front of its star, some of the starlight traveled through the planet's atmosphere before reaching Webb. Different molecules absorb different wavelengths of light, leaving behind patterns that astronomers can analyze. Those patterns can reveal the gases surrounding the planet. Webb's observations detected methane and carbon dioxide, while the atmosphere appeared to lack strong ammonia features. That combination has been discussed as being consistent with some scenarios involving a hydrogen-rich atmosphere and a water-rich interior or ocean. And suddenly K218b became one of the most interesting planets in the exoplanet catalog. But then came the detail that created even more excitement. Researchers reported a possible signal associated with dimethyl sulfide, or DMS. On Earth, DMS is strongly associated with biological processes in marine environments, particularly with microorganisms. That sounds extraordinary. But there is an important distinction. A possible chemical signature is not the same thing as a discovery of life. The DMS interpretation remains uncertain and requires additional observations and validation. The signal could become weaker with better data. It could turn out to have another explanation. And even if DMS were confirmed, scientists would still need to rule out non-biological processes that could potentially produce it. That caution matters. Because the true significance of Webb is not that it automatically finds aliens. It is that it can investigate the chemistry of worlds that were once little more than points in a catalog. K218b represents a major step in that transition. We are moving from asking whether a planet exists to asking what is happening in its atmosphere. And then from atmospheric chemistry to questions about habitability. But K218b also comes with a warning. It may not be an Earth-like ocean world at all. Its atmosphere could be thick. The planet may be far larger than Earth. The conditions beneath its atmosphere could be extremely different from anything found on our planet. Some models suggest it could resemble a mini Neptune rather than a world with a familiar solid surface. In other words, the same planet that creates hope also creates uncertainty. That is becoming a pattern. Webb keeps showing us planets that sit somewhere between what we imagined and what nature actually produced. K218b may contain some of the ingredients that make scientists curious about habitability: carbon-bearing molecules, possible water-rich conditions, and an environment worthy of deeper study. But it also reminds us that habitability is complicated. Size matters. Atmospheric pressure matters. Chemistry matters. The structure of the planet matters. And most importantly, the assumptions we make from a distance can be completely different from reality. Then Webb turned toward a world that was almost the opposite of K218b. JWST-39b. This planet is a giant gas world orbiting extremely close to its star. It is so hot that its atmosphere becomes a laboratory for studying chemistry under conditions nothing like those on Earth. There is no realistic chance of life as we know it there. And that is exactly why it matters. When JWST-39b passed in front of its star, Webb analyzed the light that filtered through its atmosphere. The result was a remarkably detailed chemical fingerprint. Astronomers detected water vapor, carbon dioxide, carbon monoxide, sodium, potassium, and sulfur dioxide.